are official. Okay, so we are going to talk about graphing quadratic equations today. Graphing quadratic equations, a lot of people struggle with graphing in other schools, right? It just, in general, I find that most people that graduate out of Algebra 1 are still confused on how to graph. You're going to learn the easiest ways to graph these things. You can do them practically in your head once you figure out how to do them, right? They're not hard. They're really actually fun to do. But we have to first talk about the anatomy of a quadratic equation, right? So a quadratic equation would be this. Y is equal to ax squared plus bx plus c. So make sure that goes down in your notes. Eric, I want you to take good notes, okay? Everybody?
Gary?
Yes.
That's 4 parts, right?
Correct.
Yeah, and then there's trinomials and binomials.
Right. So a quadratic equation is a trinomial, right? It has a y equals a trinomial, and it has an x squared, which is the reason that it turns around. That's the reason. We'll explain, we'll get into that later. But first of all, the a is actually a number. Sometimes it's an invisible 1, like y equals x squared plus 2x plus 3, right? That x squared means there's a 1 in front of the x squared. B is actually a number, and C is actually a number, okay? So we are going to talk about the anatomy of the quadratic equation, or a quadratic equation. If you understand this, it will make things so much simpler for you. So really, really pay attention in this. So A, the A in the quadratic equation tells you, let's see, so the A, which one do I want to say first? If A is positive, if A is positive, then smiley face, parabola. Smiley face, smile. Okay, happy face. If A is negative, then sad face. Right? And that's obvious, right? That's the way it is. That's the way it should be, right? You think positive, happy thoughts, you smile. So when A is positive, when that number there is positive, it's a happy, smiley parabola. It's really happy. But then when it's negative, and you think of negative, bad, horrible, depressing thoughts, it's going to be sad. Very sad, right? Okay, so that's pretty clear. Now, A tells you something else, too. If, all right, so this is the first one, but here's another one. If A is large, parabola is narrow and tall. Well, they're all tall, so I'll just say narrow. If
like a large number.
A is small, I'll give you an example in a second. Parabola is fat. Okay? So an example of that would be if I had y is equal to 10x, that is going to look like this. It's going to be very tall and skinny. But if I had y is equal to 1 over 10x, wouldn't you agree with me that's a small number? 1/10, right? It's going to look like this. Whoop. It's going to look like this. It's going to be, right? It's going to be really fat. Make sense? So A tells you a lot, right? Now, in the beginning, we're going to just be using A's as 1. You know, A is going to be 1, for at least for today. But eventually, that will get, we'll be working with bigger ones as well. All right, so now we're going to talk about B. All right, B is over here. B moves the vertex. We're going to talk about what the vertex is in just a second. Moves the vertex off of the y-axis. In other words, moves it, for example, moves it left and right. Okay? So think about a parabola. Right? There's a parabola. What is the vertex of the parabola? Anybody know? Okay.
Point where two sides meet.
Yeah, there's two sides, and they meet right there at the point. That is the vertex. That's the vertex. Right? Okay? So, if I had y is, well, I'll just stop there. B, basically, if there is a B, there's not always a B. Or sometimes the B is 0, which means you wouldn't see it, right? But if B is 0, then your vertex is going to be on the y-axis. But if there is a number other than 0 for B, it's moving left or right off of the y-axis, okay? Okay, the last thing, I'm going to just erase this vertex thing because I need that space. God, how can you guys? Not enough space for a lecture. Okay, C. C is what? Look at C for a second. What if I made x 0? Yes, Graham.
Would it move the vertex off the x-axis?
Say it again.
Does it move the vertex off the x-axis? Up or down? Yeah.
Yes. Okay. First, okay. So we'll say that we'll moves. Good job. Good thinking. Moves the vertex. Whoops. Vertex up or down. And then, what if I made x equal to 0? Look at this equation right here. If I made x equal to 0, what would you get? Y equals what? C. What do you get when you x equals to 0?
A and B times 0.
Okay, stop now. Just think about in the past when I've asked you to graph other things like standard form. When you make x equal to 0, you're finding the y intercept, right? That is true with a quadratic equation as well. To find the y-intercept, you make x 0. Well, if x is 0, that's 0. If x is 0, that's 0. The y-intercept would be c. So c is also the y-intercept. We know that the parabola will cross the y-axis at c, always. No exceptions. Okay? So that's the anatomy of a quadratic equation. Okay, so let's just review it. A, if it's positive, it's happy, and if it's negative, it's sad. And we also know if it's a big number, it's going to be skinny, right? And if it's a small number, like a fraction, it's going to be fat, right? Really wide. We know B moves it left and right, and we know C moves it up and down. We know C is also the y-intercept, okay? So, can I erase? Has everybody got these? Okay. Oops. All right. Now we gotta. Now that we know that, we can practice. Now, when you graph a straight line, how many points do you need? If remember a T-chart, you guys all remember T-charts? You know, you choose like 3 points for x, and then solve for y. If I did, you know, y is x plus 1, I would do x and y, and I would say 0, 1, and 2, right? And then I would say if x is 0, y is 1. If x is 1, y is 2. If x is 2, y is 3. Okay, so for a straight line, I just need 3 points. But for a quadratic parabola, I need 5 points minimum. 5 points. Okay, so let's say I wanted to graph this. Y, let me just get rid of this. Let's say I wanted to graph this. Y equals x squared. That's about the simplest quadratic formula there is. As a matter of fact, it's so simple, I'm going to call him standard parabola guy. Okay? I'm going to actually call him that. Whoops. Standard parabola guy. This is as simple as it gets. And it's the way that you are going to simply graph. If you understand this part, you will fly with graphing. It's easy. All right, so let's say I do a t-chart. I've got x and y. I have to have 5 points. The middle point is always going to be, think about it, the vertex. The middle point is always going to be the vertex. Now the trouble is I don't know what the vertex is. Well, I do. You don't. But so let's just, for now, let's just say 0. If x were 0, y is 0. Don't you agree with me? 0 squared is 0. I'm gonna put that in the middle. I'm gonna do 2 points below it and 2 points after it. 0, 0 happens to be the vertex, and I'll explain that in a little bit. But so I'm going to go -1 and -2. I have to, once I find the vertex, I have to choose points to the left of it, right? And points to the right of it. Why would that be important when you're graphing a parabola? Why would it be important to know what the vertex is, and then you can take 2 points this way and 2 points that way? Why would that be important? What if all my points were here, from here over? I wouldn't see where it turns around, right? If I had all my points here, like 3, 4, 5, 6, 7, it wouldn't show me the vertex. It wouldn't show me the vertex or the parabola, right? So I've got to see it on both sides. So then I would do 1 and 2. So let's try it. If if x is -2, -2 squared is 4. If x is -1, -1 squared is 1. If x is 0, y is 0. If x is 1, 1 squared is, okay, if it's 2, 4. Now, look at this. Negative, negative, 0, positive, positive. These are all positive. Well, that's interesting. So let's graph this and sort of see what it looks like. So we're going to do, let's see. Oh, God. Okay. So we've got a y and we've got an x. We got boom, 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 boom. Okay, so -2, 4. 1, 2, 1, 2, 3, 4. Dot. -1, 1. -1, 1. Dot. 0, 0. 1, 1. 2, 4. Okay? I didn't do that right. Okay, so as I now draw this, okay, that's it, right? That's my parabola. That is standard parabola guy. Standard parabola guy. Now what I'm going to suggest is, well, actually, let's try one more. Let's try now y is equal to x squared plus 4. Does it have an a?
Yeah.
What's the a? 1, right? Does it have a b?
Yeah.
What is b?
4.
Look at your look at this. In In order to have a b, it's got to have an x after it. Does it have an x after it? So b is technically what? 0, right? Because 0 times x would be nothing, right? So I don't have anything with an x in it. I just have an x squared, and I have a c. I have an a x squared plus c. I don't have a b. So if there's no b, where is the y-axis? I mean, where is the where is the vertex? It's on the y-axis, right? B is what takes the vertex off the y-axis, right? So I know it's going to be on the y-axis. I also know that the y-intercept is what? Y-intercept is your c. What's your c? 4. I know it intercepts the y-axis at 4. 1, 2, 3, 4. I know that. Okay, so now let's do a t-chart first. I just want to show you this, and then so I know it's going to intercept the y-intercept, the y-axis at 4. So I'm going to do that. So if x is 0, y is 4. If x is -1, -2, 1, 2. All right. If x is -2, it would be 4 plus 4 would be 8, right? If x is -1, -1 squared is 1 plus 4 is 5. If x is 0, it would be y is 4. If x is 1, 1 plus 4 is 5. If x is 2, 4 plus 4 is 8. Okay? So now I have to graph that. So -2, 8. -2, okay, 4, 5, 6, 7, 8. Okay, -2, 8, dot. 2, 8, dot. Negative, where am I? -1, 5, dot. 1, 5, dot. Here we go. Oh, that's interesting. Look at that. It's just, all I did was I moved standard parabola guy, y equals x squared. All I did is what? I moved him up 4 places. That's it. All this says is it's standard parabola guy up 4 places. Right? Standard parabola guy started here at 0, 0. Y is equal to x squared plus 4. I just moved standard parabola guy up 4. There's no b, so I don't have to worry about it going this way or that way, right? That's awesome. So it's really easy if you have no b. B makes it harder. Definitely makes it harder. And it's not really clear when you get to the b which way you go. There's a special formula you have to learn. All right, so what would this be? So now that we know that, let's just use a different color for a second if I find the cover. What would this be? What would y is equal to x squared minus 6 look like? Where would I put it?
-6 down.
It's standard parabola guy, right? Move down 6, right? There's nothing going this way, so I just move it down 6. 1, 2, 3, 4, 5, 6. Boom. And now I'm going to show you the beauty of standard parabola guy. Instead of doing this t-chart, right? This is what I want you to think of. Over 1, up 1. Over 2, up 4. All right? So I'm just using these. I'm just using these right now. Over 1, up 1. Over 2, up 4. Right? Everybody say that. Over 1, up 1. Over 2, up 4. That is standard parabola guy. That is your best friend. If you know that and you remember that, it will be so easy to graph. Over 1, up 1. Over 2, up 4. So I'm going to pretend that this is my origin. And from here, I'm going to go over 1, up 1, dot. Over 2, up 4, dot. Look, I'm halfway done. Now I'll go over 1 this way, over 1 this way, up 1, dot. Over 2 this way, up 4, dot. And I draw my parabola. Does that make sense? It's the same standard parabola. It's the same, yeah, standard parabola guy. It's the same ratio of movement of points, right? So if standard parabola guy is over 1 up 1, then this must be down at -6. It must be over 1 up 1. If standard parabola guy is over 2 up 4, this must be over 2 up 4, right? You with me? Now, you won't see the beauty of it until you see the hard stuff, because this makes the hard stuff easy. Easy, 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 easy. All right, sophista 5. Have I lost anybody yet? 5? You get it? Right? Okay, so what would this be? Let's do another color. What would this be? Y is equal to, this is not a good one. Let's do this one. Y is equal to, let's try this. What about if I say negative x squared plus 2?
Would it be the same thing except flipping around?
Yes! So where would the vertex start?
2.
At 2. It's got to, because there's no b, right? There's no b. There's no something x. Got to start there. Is it going to be happy face or sad face? Sad. So sad. So instead of over 1 up 1, it's going to be over 1 down 1. So sad. Over 1 down 1. Over 1 down 1. Over 2 down 4. Oh, they share that. Look at that. Oh, it's not so bad. They're in misery together. That's beautiful. Okay, so there we go. Right? It's pretty easy, right? Pretty easy. I just plot my vertex, basically, my C, and I go over 1, down 1, over 2, down 4. Right? You starting to see the beauty of this? Starting to make sense a little bit? Okay. Now we're going to get into B. Let me erase this. Can I erase? Oop, shoot. I didn't mean to erase standard parabola guy. And I probably shouldn't have erased that either. I did. Standard parabola guy. Okay, y is equal to x squared. Okay? Now, what else do we know? I didn't talk about this when I said anatomy of a quadratic equation, but what about a parabola in general? What do you notice about the parabola? If I know, I mean, it's not the best drawing of a parabola, but, you know, if I know this point right here and it's over, say, 2 places, right, from this line, what do I know about how far this one is from this line? It's what? It's the exact same. If it's from here, if I go over 2 places to the right, from here I got to go over 2 places to the left, right? And so what is that? What's the word for that?
Symmetry.
Symmetry. It's totally symmetrical. So parabolas are symmetrical, right? Okay, so would it be useful to know how to find this line? In other words, wouldn't that show me where the x is on the vertex? Like, what if I had a graph? If I had a graph, and my vertex was well, let's see. Well, no, let me just do this. This is called, I'll just change my approach here. Axis of symmetry. Okay? That is called the axis of symmetry. It's the place where on either side they are mirror images of each other, of the parabola. Does that make sense? Okay? The axis of symmetry. So there is a formula for finding the axis of symmetry. And this is really, really helpful because what it will do is it will show you where the vertex will be, at least how far on the x-axis it goes. It doesn't tell me how far on the y-axis, but it'll tell me where it is on the x-axis. So I could either use that to do a t-chart and do 2 before that and 2 after that, 2 points before and 2 points after. Or there's another way that's even easier. So let's try this. So now the axis of symmetry. This is a very, very famous formula. And it's extremely useful. Did I spell that right? Doesn't look right. I think it is. Okay, axis of symmetry. X equals, not y equals, x equals negative b over 2a. Negative b over 2a. Write that down. You're not going to memorize that. I mean, yeah, you will soon. X equals negative b over 2a. Say it. X equals negative b over 2a. Again. Again. Okay, good. When you need this is when there's a b. Okay? When there's a b, you have to know this formula. Otherwise, you could be plotting and doing a t-chart and everything, you know, till midnight tonight, right? And you might, oh, where is that doggone vertex? Where does it turn around? You know? And it would be a nightmare. And the funny thing is, when I was taught how to plot in school, when I was taught how to plot with a t-chart, to graph these things, they never taught me this. They just thought, well, let's let them practice. Let's let them use hundreds of numbers and take 2 hours to graph one thing. It was ridiculous. So this is hugely helpful. Okay, so now let's actually do one. Let's look at an equation. Let's say we have y equals x squared plus 2x plus 1. Keep it simple. All right, what is my a? My a is 1, right? Right there, that's my a. A equals 1. What's my b? 2. What's my c? 1. Okay. All right, so let's find my axis of symmetry for that equation. So x is equal to negative b. What would I put? Negative 2, right? Over 2 times a. 2 times 1. So that's just 2. So my axis of symmetry is negative 1. You agree with me? Yes? Make sense? That means if I have a graph, where am I? X is, okay, so boom, boom. Okay, it says x is negative 1. So all I do is I go over here, I go to negative 1, and I do a vertical dashed line. Whoop. Good job there. Okay, vertical dashed line. Why is that helpful to me?
Because that's where the parabola is going to
turn around, right? That's going to be where the vertex is. Somewhere on that dotted line is where the vertex is. That's really helpful. So I could, if I wanted to do the long way, I could use a t-chart. And I could take 2 points here. I could do negative 2 and negative 4. And I could do 0 and 1. You see what I'm saying? And I could use a t-chart and find my points. And because I know my axis of symmetry, I know where the parabola turns around. I don't have to spend all day and all night trying to figure that out, right? By practice and error, right? So that's huge. Now, instead of using a T-chart though, what I want to do is help you learn how to use standard parabola guide, okay? And so we know that a vertex is a point. Am I right? A vertex is a point on a graph. So a vertex will be a point, x, comma, y. Do we already know what the x is of the vertex? What did we find out when we found the axis of symmetry? The axis of symmetry was what? X equals negative b over 2a. Not y. X equals negative b over 2a. Your axis of symmetry is your x of your vertex. Does that make sense? Because I know my vertex is at -1 somewhere on the, you know what I mean? I go left, -1. It's somewhere. It could be anywhere on the, going up or down, but I know the x part is -1. Awesome. So immediately I can say, okay, -1. How would I find my y? What? I would go up to my equation, right? That's where it says y equals, right? To find my y, I would just substitute -1 in for x, right? So I'm going to just rewrite my equation. Make sure I'm on this thing. Looks like it. So we got y is equal to x squared plus 2x plus 1. So y is equal to -1. Now, is this legal? Is this right to do it right like that?
Yeah.
Well,
What did I do wrong here?
Oh, no, because it had to be in parentheses.
It has to be in parentheses. If I don't put this in parentheses, then I would get -1 here, right? It would be -1 times 1, right? It's got to be in parentheses because x is -1. X is being squared. The negative has to be squared as well. Plus 2 times, I just tend to use my parentheses a lot for these. Plus 1. So what do I have? -2 squared is? -1 squared is? 1. So y is equal to 1. 2 times -1 is? -2 plus 1. I have 1 and 1, 2 minus 2. Y is 0. Oh, great. So my vertex is -1, 0. Right? You with me? So I'm going to go over here. -1, 0. I put a dot. Now look what I have. You guys with me so far? Look what I have. What is that? Standard parabola guide. Right? Because I have now used my axis of symmetry and I have found my vertex, I now know from that vertex I can use standard parabola guide because it says y equals x squared. This stuff has already been taken care of by this. Does that make sense? By doing my axis of symmetry formula for my x and plugging that into my formula to get y. So now all I have to do is go over 1, up 1, dot. Over 2, up 4. There we go, dot. And I'll do over 1, up 1 this way. Over 2, up 4 this way. Or I could have said, well, this is 1, 2, 3, 4, right? Because they're symmetrical. Draw my, look at that. You with me? So now let's do one. Let's practice. Let's practice now. Now that you understand the process. Can I erase? Fist of 5, you sort of get it? Okay, now you just have to practice it so that it starts to be easy. Because it looks like a lot of steps, doesn't it? It looks like a lot of steps. It's not so bad. The only thing you need, if it has a b, you just need this formula. X equals -b over 2a. Then you get an answer, and you plug it into your equation, to get your x and y, right? You have your x from this, you get your y from this, and then you plot it, and then it's standard parabola guy, right? So let's do it. Let's see. Okay, here we go. Let's plot this. Y equals x squared plus, actually let's do minus. Let's say minus 4x plus 3. Okay? Does it have a b? Yeah. So if it didn't have a b, if it was just x squared plus 3, I wouldn't have to use I wouldn't have to use my axis of symmetry formula, because what would be my axis of symmetry? My y axis would be my axis of symmetry if there's no b. But when there's a b, I have to use my axis of symmetry. My axis of symmetry formula, AOS. What is it? X equals? All right. Always write the formula. Hint. Always write the formula. It doesn't, the only thing you have to write more is just negative b over 2a. You're about 10 times less likely to make a mistake if you just write that formula. Okay? Equals. What's b? B is negative 4, right? So what's negative 4? Positive 4. Over 2 times a is 1. 2 times a, 2 times 1 is 2. So my x, my axis of symmetry, that's my x, is 2. That means my vertex, what's my x of my vertex? 2. With me? Okay? Now all I have to do is what? To find my y, what do I have to do? I plug my x back into my original equation, right? So here we go. Y is equal to, I'll just write it, x squared minus 4x plus 3. So I have it. All right. So y is equal to 2 squared minus 4 times 2 plus 3. 2 squared is 4. So y equals 4 minus 8 plus 3. What's 4 minus 8? 4 minus 8. Negative 4 plus 3? Negative 1. So y is equal to negative 1. I now have my vertex. If I graph this, once you have your vertex, like you're 90% done. If I wanted to do my axis of symmetry, I'll just do that. It says it's 2. I'm going to do a vertical dashed line at 2. That just tells me that's my axis of symmetry. And then my vertex is 2, negative 1. I go over to the right 2, down 1, put a dot. Now I'm going to use standard parabola guy. Right?
And what was that? That was
Okay.
right. That was up 1.
Over 1, up 1. Over 2, up 4. Over 1, up 1. Over 2, up 4. Right? Basically, if you ever forget, when x is 1, y is 1 squared, which is 1. Over 1, up 1. When x is 2, y is 2 squared, which is 4. Over 2, up 4. Right? There we go. Oh, here's my dot, right? Over 1, up 1. God, that looks a little too far. Right. Over 1, up 1, dot. Over 2, up 4, dot. Over 1, up 1, dot. Over 2, up 4. Or I could have used my symmetrical thing. Oh, that's 2 over, that's 2 over. But either way, there's my graph. Easy. Easy, easy, easy peasy. Yes?
What happens?
Go ahead. Listen.
Okay, what happens if, like, your vertex for the y, what if it turns out to be, like, a fraction, or what happens if one of them is a fraction?
If you're what? If you're...
If one of your, like, your x or your y is
Yeah,
a
great
fraction.
question. let's say x was a fraction, then plugging it in is kind of a bummer. It's a little harder, right? And a lot of times you wouldn't be like, let's say your vertex would end up being sort of in between places. Do you see what I'm saying? Like, let's say your vertex, I'll use a different color because it's a different problem. But sure, this is fine. Let's say your vertex was let's just do something. So negative 3 1/4, comma, negative 2 1/2. Okay? Let's say that was your vertex. That's kind of a bummer, but we'll try it. 1, 2, 3 1/4. So somewhere around there, that would be my axis of symmetry, right? It's a bummer because it's not right on a point on a whole number. And then negative 2 1/2. So I got to go down 2, 1, 2, and then 1/2. Somewhere around there, somewhere, right? Now, when I use, let's say let's say it is y equals x squared, meaning standard parabola guy. So then I would have to go, even though it's not in, it's like in the middle, right? It's in the middle of this stuff, right? I got to go over 1, up 1, halfway. Does that make sense? Over 2, up 1, 2, 3, 4. You with me? You kind of have to make sure whatever you go over 1, it's a full 1 from wherever you started. And it's just harder, but it works. It works. And usually, too, when you're graphing, it's not, I mean, especially when they're fractions, it's never totally precise because your graph is, you're guesstimating, okay, where is 1/4? You know, where is 1/2? Where is 13/16, right? Who knows where 13/16? I mean, you know, you just have to guesstimate. So when they get to be fractions, you just do your best guesstimate, you know. I mean, it's as accurate as you can be, but it won't be exact, perfect, right? Does that make sense? Do you get these? So gosh, the class is now officially over. But that's it, we finished. That was a very long lecture. Good job, you guys. I've got the homework here.